This is lesson 56B, areas of segments. First of all, we've got to define what a segment is. We already know what a sector of a circle is. It's this little pie shaped, it's a sector. But if I were to take that pie shape right there and say that's my sector, this right here would be a segment, which would be when I take a chord of a circle, right? If I took any chord, that little segment of that circle that I've shaved off. And I went ahead and highlighted that in. Now, I'm going to jump right into the example on this one because it makes more sense as you see how to find this area. Really, in a nutshell, what I'd be trying to do is say if I knew the area of the whole circle, that's great. If I knew the area of the sector, that's the part of the whole circle, that's fine. But I need that segment, that little piece. Well, if I knew the area of this triangle, I could take it away from the area of the sector, and that would give me this little area of the segment left over. That's the easiest way to find out what that area of that little segment is. So, and I've written that down. We know the formula for area of a circle, pi r squared. We know the area of a sector is the part of the circle, right? So it would be, if this was a 90-degree angle, I would say it would be 1/4 of the area of the total. If it was a different piece, I would multiply that by the total number of degrees divided by 360. And we're going to see here in a minute, that works for radians as well. Example 50. The example that 6.4 that they want us to start with here wants us to find the area of this segment right here, and they've given us some of the details here. They're saying that it is a 0.6 degree radian, or not degree radian, 0.6 radian angle here, and the radius is 10 feet. And I get so commonly we use the degrees, but we're going to switch to radians in here. I will correlate that back to degrees here in just a minute so you can see why that's so important. But I have a 0.6 radian angle right there. So I know that the area of the sector, well, how would I find the area of the sector? The area of the sector is the area of the circle, right? The part of the area of the circle. So pi r squared is the area of the circle multiplied by 0.6 of 2 pi. Now, why am I using this? 0.6 is a what? It's a radian measurement. So I would say 0.6 of 2 pi. Why am I using 2 pi? Because that's a whole circle. So I'm saying 0.6 of the whole circle, right? For my radian measurement, and I go ahead and multiply that out. I say 100, which is 10 squared, right? That's my r squared, times 0.6 divided by 2, and that's 30 feet. Really simple. And the reason why you're going to find out that radians aren't so bad, we will use them a lot more going forward, is that things like this happen. I didn't have to worry about what pi r squared was. Pi just canceled out. I'm left with r squared divided by 2, multiplied by 0.6, or the other way around if you want to say it that way, 100 times 0.6 divided by 2, so 60 divided by 2 is 30. Now, that's the area of the sector, but I need the segment, so I need the area of the triangle. Well, the first part of this lesson in 56 was talking about how to find that triangle when I knew a angle, but I don't know the height. So I dropped a line for a height there, and I'm going to go ahead and find that height to find out what this is. So what do I know about this? Well, if I wanted to look at this angle here, if I know that angle and I know the opposite and I know the hypotenuse, I know that the trig function that's going to work with that is my sine. So the sine is opposite over hypotenuse. The sine of theta equals h over r, and I plugged in my variables there. So r sine theta equals h. Well, what is r? 10. So 10 sine of 0.6. Now this is where I'm going to hit the pause button. Stop! 0.6 is a radian measurement. Your calculator does really well with finding radian measurements just as well as it does degrees, and I don't have to convert to degrees to do this. I do have to hit the mode key on my calculator, and mine went to sleep here. I do have to hit the mode and come down here and select radian instead of degree. Now, when I do so, I'm going to get, and I can plug it in, 10 sine 0.6 is 5.65. If you don't get 5.65, you're in degrees. Now, many of you at this point are saying, wait, I like degrees. Degrees make sense to me. They're how you learn how to think of angles. And so if you did so, if I had said, well, what is 0.6 radians? 0.6 radians, there's 360 degrees is equal to 2 pi radians. And if I multiplied this out, I would get 34.3775. That's this angle. And if I did 10 sine of that in degrees, 37.3775, I would get 5.6464, which is 5.65. Now, if you really want to go through the extra steps of converting to degrees to then use your trig function that you know how to work with in degrees, that's fine. But I don't see the reason to go through these extra steps when I can just simply use the menu key and mode key on my calculator and convert it into radians, and then I can plug it directly in. 10 sine 0.6 is 5.65. Now, that's my height. My area is 1/2 base times height. So 1/2 of 10, because it doesn't really matter that that happens to be the opposite as well. Or the hypotenuse of my small triangle happens to be the big triangle I care about here. So my radius is 10, that's also my base. 5.65 is my height. I take 1/2 of that and I get 28.25. 28.25 is the area of this triangle. Now keep in mind, if I know the area of the triangle and I know the area of the sector, I can find the area of the segment by subtracting the area of the sector from the area, or the area of the triangle from the area of the sector. So the area of the segment equals area of the sector minus the area of the triangle. Well, I know the area of the sector was 30, and I know the area of the triangle is 28.25. When I subtract them, I end up with 1.75, and that's the area of this little sector. And that's the segment. This is the easiest way to find areas of segments. Now, they will throw them in this book with you with both degrees and in radians. I chose to show the radian one because I feel that that's a little more foreign for you, although I would have done the same steps exactly if this was in degrees. I just would have worked with it in degrees instead. And it does work out nicely either way.